So today's lesson is we are talking about the illumination. The illumination is based on the light. Light is a kind of the electromagnetic energy. So it travels with the speed 3 multiplied 10 power 5 kilometer per second. So light can be deflected or distorted. Here is a frequency range. So this is for the frequency range and the wavelength of the electromagnetic wave. So between the range of this range, it will be visible. So this is the visible range. So about the 10 power 50, the speed, that range is the frequency 10 power 15 hertz. So that range, you can see the light. So light can be depending on the frequencies value. So it can be wavelength nanometer. Depending on the wavelength nanometer, it can be like red, yellow, violet, like this. So about the gray, so this is for the 400 nanometer. Red is the 700 nanometer, and violet. So this is for the electromagnetic spectrum or the light. So between this range, you can see the light. Then we are talking about the luminous intensity. Luminous intensity and luminous plus calculations formula. So this is the lighting times and the unit. Luminous plus unit is a lumen, the symbol is a F. Illuminant is a unit is a lux or the LH, symbol is a E. Luminous intensity a candela CD, symbol is a I. Illuminant is a candela per square meter, so CD per meter square, and U symbol is a L. So 75 watts incandescent lens are given the 900 lumen, and 39 watts of fluorescent lens is given out the 3500 lumen, and 250 watt high pressure sodium lens is given the 30,000 lumen. So this is the kind of the lens and their illumination level. So luminous intensity can be calculated as 1 candela produce a luminous plus, and 1 lumen on the 1 square meter at a density of the 1 meter. So the 1 candela means it produces a luminous plus 1 lumen on the 1 square meter at the density of the 1 meter. So this is the luminous efficiency calculation. From here, light is producing the light power. So when you provide the electrical sub connected to the electrical power, so light producing this light power. So this is we call the luminance. So the ratio of the luminous plus to electrical power input is this is the efficiency N. So N equal to FIP. So in this case, N is a luminous efficiency lumen by watt. F is a luminous plus lumen, and P is a input power. So this is the ratio between how much luminous plus can be produced by providing the input power. So the light rays can impact and reflected from the square surface. This is the specular, and here is a diffuse, and here is spread. So depending on the reflection, we can get this specular, diffuse, or spread. So we also saw the one problem. A light source produce a luminous plus on the 1000 lumen if all the produced lights fall onto the surface, having a surface area of 10 square meter, determine the luminance on the surface. So in this case, the producer total plus is a 1000 lumen, area 10 meter square. We have to calculate the E. So E is equal to FIA, so 1000 divided by 10, you got 100 lux. A room with a flow measuring 3 meter by 5 meter is to be live with the illuminant of the 200 lux. A square is so reach the flow, we need to calculate the necessary luminous plus to achieve this. So in this case, flow area is 3 into 5, so the 15 meter square. E is 200 lux, so the E equal to FIA, so the F equal to E multiplied A. In this case, E is 200, F is 15, so you got the 3000 lumen, we can calculate that. So here we can calculate this light. So here this is the area. So that is a luminous plus. Then we can calculate the candela. Here is all the lights fall on the surface area A equal to FIA. And here is the distance. The distance the D is the area. So in this case, E equal to I by D square. So if this one is directly perpendicular, but if the angle theta here, so E equal to I by D square cos theta. So this is the way we calculate the equation. We need to calculate the illumination on the surface. There is a 3 meter distance from the 200 candela light source. So in this case, E equal to I by D square. So the 200 candela is I is 200, D is 3, so 3 square. So the 200 divided by 3 square, you got the 22 by 2 lux. And also that we also need to calculate the 2,500 candela light source and mounted in a 4 meter above the floor. So here 200, 500 candela light source 4 meter above the floor. We need to calculate illumination on the floor directly below the light and a point on the floor 3 meter distant from this 3 meter distance. So we also have to calculate the illumination E. So the for the directs are directly perpendicular, E equal to I by D square. So in this case, I is 2,500, D is 4 square. So you got that when you can calculate this one. And then also this angle theta need to calculate that. So that this is the opposite side 3 meter and adjacent side 4 meter. So then theta is 3 by 4. So theta is tangent inverse of 3 by 4. You got that 36 by 8. So the I equal to E equal to I by D square cos theta. So the 200 by 4 square and you got 36 by 8. So you got the 10 lux. You can calculate that. So the question answer, what material is used for the filament of the incandescent lamp? And name the 3 basic types of the reflector. What is the efficiency of the following light source? High pressure mercury vapor. Give the definition of the maintenance mode operation of the emergency luminaires. Typically, fluorescent lighting is not used for the illumination with the mounting height greater than the 6 meter. So high base fitting that has the appropriate beam spread and the 46 to 60 is classified as the medium spread fitting. So in this case, light is a mix of the tungsten, and there are 3 suppression, specular, diffuse spread, and mercury vapor is given the 32 to 63 luminance per watts. Then is operators typical. Then is operators by the supply and continue to operate on the battery supply. So this is the maintenance mode. Here is this is the illumination classes, and also that they are angle degree. So this is also you can see it. Okay, we are talking about this is for the kind of the illumination. This table show the high density luminous class and they are suppression, how much spread and what will be the angle. So they are table, you can see it. Okay, we are talking about the luminaires. Luminaires are designed to support and provide the means of the electrical connection to the lamps and to distribute the light produced by the lamp in the most effective manner to the task area. So task of the task to perform is a lamp lumina plus and position of task area and recommended task luminance and a visual comfort. Those are the tasks to perform. And also they are with the direct is that 90 to 100% of the light is direct from the source, and 0 to 10% of light received is reflected from the source. So this is the direct lighting system. Semi-direct means that 10 to 40% of the light the received is direct from the source, and 60 to 90% of received light is reflected from the surface. This is the indirect. 0 to the 10% of light received is direct from the source, and 90 to the 100% of received light is reflected from the surface. So this is the kind of the direct, indirect, and the semi-indirect. So that kind of the system, how much light is produced, how much will be received. Here we are talking about the shearing angle. The angle between the horizontal and the line on the side at which at any point of the high luminance on the left and luminance become visible. So this is light here, this is light fitting, and this is light shearing. This angle is a light shearing angle. Light here, light fitting, light shearing angle. The angle between the horizontal and the line on the side at which at any point of the high luminance on the left and the luminance become visible. So this is for the illumination design. This is illumination design system. So light beams are present, so that depending on this angle, this is beam will be separate like this. So this is left here, this is angle. So that we can draw the illumination and the angle, we can get the light. So this is the beam on the spectrum. Beam on the spectrum is the angle in the plane through the beam axis over which the luminous intensity draws to the stated value or the free value. So usually these are 50% or the 10%. So this is approximately to the at least 1680. So this is the glare control method need to be utilized. Here is a illumination design. The lumen method we can calculate N equal to EA divided by NF and F into UF. N is a number of the luminance required. E is a required luminance flux lux and area. M is a number of length by the luminance. F is a length lumen output lumen, and M is a maintenance factor. In this case, maintenance factor depending on the dust of the agent of light bar and the cleaning rooms surface. UF is utilization factor. This is the functional luminance properties and the room geometry. So in this case, we can also calculate the room index. Room index can be calculated LW divided by L plus W into HN. In this case, L is the length of the room, W is the width of the room, HN is mounting height. So this is maintenance factor need to be given from the program. When we calculate this problem, a general open plan office has a dimension 12 multiplied 8.5 multiplied 2.8 meter, and the required luminance is a 330 lux. The reflectance of the ceiling is known to be the 0.7, and the reflectance of the wall is a 0.5. The wall area depths are at the height of the 0.8 meter. The luminance are the 22 with the each juice, beam at 36 watts daylight. 2850 lumen, direct, indirect, tied with this UF factor. So here is a table here. This is reflected as a room index table here. So this is the light. So this is for the room reflectance value. Reflectance value is so this CWF is given here. So there's 0.7 and the 0.5 the reflectance value, and also the table here you can see the room index factor. So this is here 2.5. Is a 0.55. So this is the room index factor. In this case, C is a ceiling reflectant, W is a wall reflectant, and the F is a floor reflectant. So ceiling, wall, floor. So the 0.7, 0.5. So this value is given. This is room index K. Depending on the room index K, this way can be also we calculate the reflected value. So the first is we calculate that for the K value. K value is LW by L plus W to HN. So 12 into 8.5, 12 plus 8.5 into 2, so you got a 2.5. So the utilization factor is a 0.55, C is a 0.7, W 0.5, and the K 2.5. So those things you can get from CW and the K value, you can get from this table. Depending on the row index, you can get the CW and the K value. So that then you substitute in this formula. Angle to E is divided by NF and F into UF. So in this case, E is a 320 last, A is a 12 multiplied by 8.5, F is a 2850, and F is a 0.8, UA is 0.55. So from here, those things we can calculate that. UF is this is our UF value calculation. This is the 0.55 depending on the row value, CWF value, and we can calculate the UF value from this table. So this one UF you calculate it, and after that you substitute this formula. So that this formula you substitute, you got the A is 13.01. In this case, 13.01 is we can select the 14 or 15. And 14, if you select the 14, 2 row, each row got a 7 line. If you select the 15, you have to use a 3 row and each row got this 5 lines. So this is the way we calculate that. So that will also be that we calculate all the row ratio method. Now the row is A, which other row is B, mounting height A. In this case, row ratio can be calculated AB by H into A plus B. In this case, a row index method is a dependent row ratio method. This is the English and USA system. So if you got the row ratio method, you can select the E, A, B, C, D, and this is the row ratio value. And this is for this table is a utilization factor C. So depending on the reflection factor of the ceiling and also row index, depending on the reflected factor, you can calculate the utilization factor. Here is a reflected reflection factor 75%, 50%, 30%. So this is reflection factor of the wall 50, 30, 10 like this, and this is row index. So from here the row index and the reflection factor, you can calculate the utilization factor value. So N is a E, F, C, and the value here calculated. E is an aluminum, A is an area, F is a light output. So this is number of light multiplied each light output. N is a maintenance factor and C is utilization factor. So this formula you can start to calculate. You can calculate the number of this maintenance factor. Okay, so this problem we have to calculate the design the illumination for a classroom. The length is a 6 meter, and which design the illumination for the classroom 10 meter long and 6 meter wide. Ceiling height 3 meter. The ceiling painted with the white, so in this case reflection factor is 75%. The wall are painted with this with the color. So having such a reflection factor is 50%, 250 light is to be taken. So in this case, for the classroom, you have to utilize 250 light. So this is for classroom, the standard illumination factor. And we have to use as a twin fluorescent lamp producing the 3000 lumen each lamp. So what area usually is at the 0.8 meter. So in this case, we calculate the mounting height is 3 multiplied 0.8. So that's 2.2 meters. So H is 2.2. Because of the total ceiling height 3 meter and what area is 0.8 meter. So 3 minus 0.8, you got a 2.2. H is 2.2. It is the length of the row is 10 meter and width of the row is 6 meter. So that we substitute in this formula. Row ratio is AB divided by H into A plus B. So 10 multiplied 6, 2.2 into 10 plus 6, you got that 1/7. So from the table, row ratio 1/7, row index E, because of this table you utilize. This is the row ratio is 1/7. 1/7. So row index this table. Row ratio 1/7. So row index is E. Row index we can calculate the E. So the utilization factor is 0.42, and then maintenance factor is 0.8. Maintenance factor you have to assume that 0.8. So utilization factor and also the maintenance factor you can calculate that. So utilization factor is you can get from this table. From these reflected value and row index, then you can calculate utilization factor. Depending on reflected value and the row index, you can get from this table, you can calculate the utilization factor. So the utilization factor here we calculate is this is the reflection factor. So this is reflection factor value here, the row index. So reflection factor is 50%. Row index is E. So this table you got the utilization factor is 0.42. So this table you get the From here, you got a utilization factor. So therefore, that you substitute a utilization factor 0.42 and substitute here. Then, based on the this value we are, you can substitute here. So E is at 250, A is at 10 multiplied by 6, F is at 6,000, utilization factor C 0.42, and number N is 0.8. Then you got the 0.713 or 8. So in this case, 8 rows, so that we can arrange a 2 row, and every row got the 4 units. So that will be the arrangement. So today we're talking about the emergencies. This is we're talking about the lighting system lessons. Then we can talking about the trade 2, electrical engineer trade practice. Okay, so electrical engineer trade practice 2, we are talking about the connection of the load relays and the tie cloud. So if you are connected to load relay and tie cloud, this is the arrangement. Single element hot water unit. So this is all the load control devices are wired on the main switch board after the kilowatt hour meter. This is installed is a measure the energy usage of the control load. The load must not exceed the 25 MVA. So here is a supply point and service fuse. This is a domestic rate meter, and here main switch and connected to the load. And here is connected to the OP meter, OP control system, main switch, and connected to hot water. So here is a service neutral and a consumer neutral link. So this is the arrangement of the single element hot water unit and connected to the domestic rate and main switch, and also OP meter, OP control, main switch system. So this is the US elements of hot water unit. The commonly referred to as a twin element. The hot water unit requires the main heating element, which is a bottom element, to be connected to the load control device. The top element is referred to as an auxiliary booster element. It's still connected to the load tariff, but not controlled by the control device. This element has a continuous supply to it, and it's wired from the left side of the control devices. So this is called the connection. Service here, domestic meter and the main switch. Here is a service neutral, consumer neutral, OP meter, and also connected to the hot water, OP control, and connected to the main switch. So this is the line diagram of the basic equipment arrangement of the US element. So this is US element connection the line diagram. So here we can see the connection of the load electronic metering. So electronic meter is programmable, and this is also the vast array of the feature and the metering configuration. So this is the standard domestic or the controllers metering system. So in this case, this line diagram. So this line diagram is a connection for the single phase and the off-peak tariff. So single phase tariffs we supply the main switch for the light and the power circuit, and off-peak tariff we supply the two-post main switch for the twin element hot water unit. So this is for the connection of the single element. So here connection diagram, main switch control, light, power, service fuse, service neutral link. This is connection of the electronic metering and connection of the single phase and the off-peak tariff system. So this is the connection diagram. Now we are talking about the hot water tariff. The supply authority distribute the electrical energy to hot water system and other suitable heating load at a number of numerous basic rates. Quotidian energy available are 24 hours per day. controls are continuous or register hour. Controls are continuous meaning restricted hour or the extended off-peak. It supplies available for the 2 hour days or not available for the morning and the evening peaks. Off-peak rate is 10 to 8 to 10 hours per day. This is between 11 p.m. and 7 a.m. Time of the use, TOU, where the energy charged at the varying rate dependent upon the time of the day is used energy at the peak time of the days are charged at the higher rates compared to the energy used at the lower demand times of the day. So this is as a water heating tariff checklist. The water storage capacity you need to check. Water storage capacity for the connection or the starting tariff or the what are the supply authority regulation and reading element, current power rating, and are there any restriction on the regarding a non-simultaneous operation on the multi-base element units such as the peak and the booster element. What is the specific operation measurements are required? So those are the you have to check for the tariff system. So common domestic storage units for continuous tariff supply. Common domestic storage unit for continuous tariff supply is a 4 kilowatt, 80 liters heating, having a recovery rate over 70 liters per hour for the 40 degrees centigrade temperature rise. So the continuous rates are required no special tariffs, but the usual power rating are the such that the rates are finite such are necessary. So this is the common domestic storage units and the continuous tariff system relationship. So the storage for the storage system or for the off-peak rate, so it needs to meet the local requirement. Is the storage capacity is adequate? Some supply authority will not supply the solar hot water system at the off-peak rates. So here we use there's a continuous control storage water heater fitted with the booster element. So this is we use a unitarist heater. Lower element is the main element. This is we supply at the off-peak rate and the off-peak metering. Top element is a booster element. So this is we are supplying at the normal rate controlled by the consumer main switch. To reduce the demand, and interlock arrangements may be required between the two elements to prevent them being on the supply simultaneously. This is a peak top and the lower element. We have to utilize the appropriate interlock devices because of the top lower element is subject to the off-peak rate and the off-peak meter rate. Top element is a booster element is a normal rate controlled by the consumer main supply. So this is why to reduce the demand, the interrupt arrangement may be required between the two elements to prevent them being on the supply simultaneously. So this is usually incorporated into the thermostat or the storage heater unit. So we allocate the thermostat, we put the thermostat in the storage heater unit to interlock the lower element and the top element. So the dual elements are 24-hour off-peak storage system. So it requires the interlock. Minimum capacity storage tank is in relation to the size of the household. Top thermostat is turn on the heat at the top of the tank. If the cool water level rise to the depth. Boost elements are fed throughout the off-peak meter. Only bottom element control off-peak are controlled separately. Two activities and the neutrals must be run to the unit from the switchboard. So the neutral commonly switch to the top bottom element by top thermostat to prevent the simultaneous operation of the both elements. So this is a question and answer. So give the location where the hot water unit isolated switch may be installed. The answer is additional to the ND's automated switch incorporated in the hidden structure or the install adjacent but not on the water heater. So the approximate AS 3000 2018 division 4/8/2/3. How is the temperature of three-phase instantaneous water heater be controlled? So this is the control by the water flow. So this is the flow switch control. Simple flow switch control switch off the element to prevent the water overheating. If the flow rate is required too much, flow rate is reduced too much. And what safety devices are fitted to and non-vented storage are electric water heaters? This is a question. This answer is the temperature and the pressure relief valves are installed. And question number 4. How do these safety devices work to prevent the tank from exploding? So a safety device called the temperature and pressure relief is normally fitted on the top of the water heater to damp the water if the temperature pressure becomes too high. And question number 5, if one of the safety devices in the question 3 fails, that temporary measure may be used to get the heaters operation. So that problem can be fixed by the plumber. Answer. And the question 6 is, under what condition may continuous supply type storage water heater be recommended as an off-peak storage water heater? This is the answer. Provider accepted model can be used. And question 7. Compare the kilowatt rating for a typical three-phase simultaneous water heater to that for an off-peak storage heater and explain the need for and is the difference. So answer is an instantaneous electric water heater typically requires the high power inputs, particularly if more than one unit is running at once. And question number 8. What is the best location for the water heater in relation to the hot water outlet? Is applied especially if the outlets are spread through the installation. So this is the answer. By locating the heater close to the point of use, it will reduce the amount of the time to travel from the water heater to outlet. And question number 9. What temperature setting range is recommended for the thermostat in the storage heater in domestic installation? That is answer number 9. So in this case, above 70 degrees centigrade, we have to use, it can die instantly. 60 degrees centigrade, 90% die in 2 minutes, and 50 degrees centigrade, 40% die in 8 to 124 minutes. 48 to 80 is can survive, but not multiply. So this is for the how to control the bacteria with the temperature. And name all the 2 types of the system of the water heating, which are more efficient than the conventional electric storage water heater. So that can be the airs through the heat pump or the 10 use water heater system. And this is a question, what advantage of the system? In the question 10. So the advantage of the system in the question 10 is the main disadvantage associated with the air source heat pumps are listed below. Lower the heat supply compared to the oil and gas blower, so larger radiator size is needed. They perform better with the underflow heating and one air heating and work more efficiently when they coupled with the larger radiator. So this is they are the properties. So here is you can see there's a thermostat connection diagram, connection of the thermostat, and also the testing method for there's a thermostat. So thermostat is controlling the heat of the system and also testing method. So this is semi-step connection, and then conducting, and this semi-step testing method, testing diagram. So how do we design the semi-step? Apply the small quantity of heat sink on the end of the digital thermometer probe and mount it on the large providing from the thermostat side of the panel. Adjust the top thermostat to 65 degrees centigrade and bottom to 75 degrees centigrade down on the supply. And we have to know which line is on. In the heating element is a top or the bottom or the down of the switch controlling the element that is not on. This allows the operating element and thermostat to cycle on and off so that the temperature range of the operating thermostat can be monitored. So this is what the how to arrange the temperature range. So this is semi-step and this is a connection diagram, and this is the method. This method is how the temperature range can be monitored. Operating thermostat can be monitored. So that you have to monitor the temperature of the heat sink and measure with the thermometer and which the thermostat down on and off. So this is what the temperature cycle down and off, and also different degrees centigrade. So this is also the a connection of the control diagram. This is the element, and this is for the load and pylon light. So this is the in the heater. You can see the test control. You can connect to the control. Okay, electrical trade tools we talking about the heating turret, and we are talking about the control method of the thermostat and the semi-step, and also the controls questions answer related to the control and the connection of the water heater system. So then this is for the trade 2. Trade 1 are electrical workshop practice we are talking about. So we are talking about the material used in the electrotechnology. So in the electrical technology system, we are using a different kind of material. So the metals are the pure metal elements. They include as iron, copper, gold, silver. The compound we are also using the mild steel, stainless steel. So in this case, mild steel and stainless steel are the combination of iron and carbon. Depending on the percentage of iron and carbon, so it can determine the properties of the steel. And also the brass is a copper and the zinc combination. Bronze is a copper and tin combination. So that depending on the iron and carbon, it can distinguish it from the other material, determine the usage, and vary with the change to the name affects especially the temperature. So this is the properties of the steel. Depending on the carbon percentage, it can determine the characteristic of the steel. Then we are talking about the heat treatment. We have to do the heat treatment to get the required characteristic. So this heat treatment method is to harden the metal or to change its properties to make cutting tools such as the file and the saw blade. So that to make the file and saw blade, we have to do the heat treatment. So the mechanical properties of the metal can be any force or load applied to the piece of the solid material. They can cause the stress to be present within the metal, or they tend to try to change the shape. The strength of material is the strength is said to be the ability to withstand the stress without the failure. So the compressive stress we have to calculate. The resistance to squeezing or the scratching forces. So this is the compressive stress. Tensile stress is to resistance to pulling or the stretching forces. And then we also start cutting the metal with the saw. So this is shear stress. The resistance to force trying to cut through the material. So the plastic deformation originates here when you put the force it will be the permanent change. But it can go back to original. This is for the elastic information. So after fully remove back, the material may remain in the shape. Force on it, so the material is suffer the plastic deformation. Plastic deformation is if it's returned to the original shape or the spring back, so it's not permanently changed. So it happens to the elastic deformation. So especially the spring. When you press the spring, it will compress but go back to normal. After you remove the force, it go back to normal. So this is the elastic deformation. Brittle means that the metal descends to the pressure under the impact of the shock. Low said to be the brittle. So the metal is when you put as a force on the impact, the metal is destroyed. So this will be the brittle metal. That means that the metal that is said to resist the pressure under the shock load is said to be tough. So especially the hammer head is tough. And hardness means that hardness is the ability of the material to resist the indentation and the wear. The softer the metal, the easier it is to cut the shape. So two must be harder than the material being cut. This is why the pie chaser hammer must be hardened. The stability is when you put the force on the metal, so that will be the cross-sectional area is smaller and smaller, and length will be longer and longer. This is we call the ductility. So to produce the copper wire, the piece of copper is stretching, it causes a reduction in diameter, increase in strength, and the source. And also the soft loads and tensile strength can happen. And malleability. Malleability is a material that can be beaten to the shape is said to be malleable. So that the load can be easily shaped with the hammer. The type of metal used in the electrical technology are the copper. Coppers are we use for the electrical wiring, pipe and tanks. This ability to conduct the electricity and heat, and also is possessed as a corrosion system, easy to force or to the shape, and also the not easy to cast or machine. Copper alloys are the better to resist the corrosion, especially the brass is a copper and zinc combination, and bronze is a mixture as a compound material of the copper and tin. Aluminiums are the cheap and widely used in the industry. It's conduct the heat and the electricity well, also resist the corrosion, density 1/3 of the steel. So this is aluminium, so alloy aluminium. When you are alloying the aluminium, alloying the aluminium, we can this is magnesium, titanium, and beryllium. By combining aluminium, it can become the aluminium alloy. They become strong and lightweight and used for the casting. Ferrous metals are the steel, cast iron, and stainless steel. Steel is a product depending on the amount of carbon. Low carbon steel are the 0.25% of carbon, so they use for the framework, cabinet, board, nut, screw, nail. Medium carbon steel are 0.5 carbon percent. They are harder, they are tougher, they are the high tensile board, gear, and the machine parts we can utilize. High carbon steel, 0.8% carbon, so they are stronger, harder. We use for the spring, spanner, handle, alloy, and carbon 2 steel as a 1.5% carbon. They are used for the varies a 5-2 shifter, strapper. High speed steels are contain the tungsten, so it's we can use for the cutting tool and drill. So depending on the percentage of steel, percentage of carbon steel can be the property can be changing, and we can use for the different kind of the materials. And stainless steels are the steel and the nickel and chromium combination. This is the corrosion resistant, but they has no magnetic property. Cast iron is an iron and carbon compound, carbon 2 to 5%. So this is easily melted, poor to mold to produce the casting, and they are cheap, they're strong, composition, resistant to wear. They're suitable for the heat treatment, used for the machine base. The type of the plastic used in the electro technologies are the process of the building up from the simple chemical process, they're from the petroleum. We can use the process to plastic, that they are also the good insulator. So chemical structure, depending on the chemical structure, is a petroleum chemical structure. Launching of carbon and hydrogen atom, they are excellent thermal insulator. So plastics are the thermostatic and thermoplastic. The property is when the heat provided, it will be solvent, so that when cool, it will be solidified. So thermoplastic is a thermosetting plastic is a cannot be remelted or solvent by the heat after they have been solidified. They undergo chemical change when heated. So they are kind of the bakelite is the electrical we use for the electrical equipment, distributor and the grinding wheel, polyethylene we use for the stone. They are strap, they are flexibility and good adhesion. We use for the cushion material, carpet, underlay, safety padding, and safety helmet. Epoxy resin is we use for the chemical resistant. They are good adhesive, material adhesion, and the ceramics are flushing and the surface coating properties. Thermoplastics are the polymer chain can be resolved by heating the removed by the heat. So polystyrene is a heat low heat resistant. They are good modulus molding quality, low solvent resistant, molded food, drink container, and kitchenware packaging. We use a polystyrene. Cellulose, they are the high investments and poor heat conductor, resistant to oil and detergent. We use for the screwdriver handles, photographic flame, and recording tape. Polyethylenes are the tar resistant solvent, low moisture, absorption, and flexible. Polyvinyl chloride PVCs and non-toxic high strength, adhesives are resistant and the ROS are proof. We use for the cable coating, recorders, and conjuice. Polymers and the nylons are the high tensile investment. They are low coefficient of the friction, VR resistant, purchase, gear, and the washer. Fluorocarbon PDFEs are the non-stick coating, C, gasket, and the bearing. They are using all the raw material. Acrylics are the this is for the they are clear, they are transparent and good electrical resistant. They got the safety sheet and they also the windscreen and also the taillight lens are also included. Acrylatides this was like high tensile investment. They use for the crash helmet, safety helmet. We also utilized. So this now we are talking about the use of the electro technology material. Then we are using this blending process. We use a different kind of the pressing. In this case, before you starting the before that is undertaken, you have to do the blending process. So you have to do the reassessment. Reassessment how does a person, how can have a person any workshop process, you have to do the reassessment. How can have a person usually likely, unlikely, very unlikely. If you kill or everything sick, long-term illness, and medical attention, so extremes are important to the low attention you can put on the scale 1 to 6. So, scale 1 to 6, you have to put. So the this is for the how the person is damaged, and here is a scale or the long-term illness or the medium attention. So that this will be the above the damage level is a column. This rule is a how likely happen. So this is then you have to phase the factor. So 1, 2, 3, 4, 5, 6. You have to phase the factor by doing the rate assessment. So that this is why we have to do the discover the hazard, describe the how important this table. Dealing with the hazard is the best thing is the remote and the lesson. Keep checking the new hazard. You need to collect the information. So in this drawing plan, personal protective equipment, location of suitable site to perform the task and disposal of waste material, and also understand the required technology, available safety and the quality use of the required tools. Those are the important for the reassessment and to perform the tasks. Then we also talking about the fix and screw out the electro technology equipment. So in case we are talking about stub partition hollow wall. So this is the your hole is usually the brick veneer hole. So this is veneer and this is for the hollow. From the hollows we can run the electrical wire or the plumbing pipes. Wall construction can be the timber, metal stud, or plaster board. So it can require different fixing method. facing the wall is you have to locate the stud within the wall. Before that, the underneath, there will be any stud, so you have to locate the stud. There can be the male or the pipe or wire. So in this case, the line at the prison point used as a stud finder. So you have to fire out a stud finder until the mark is solid hard. This is indicate the solid elements behind it. So that we are also always check the any pipe or hidden in the area. So that we are using the facing accessory. The accessories are that we use a screw, we use a driven through the plaster bolt into the stud, and to provide a very secure facing. The plaster bolt screw, also the buckets are shader head. So this is to countersink neatly in the plaster bolt without crashing. So this is the correct thing. This is the round. And this is 0.6 mm thick timber, thin steel. We are also used for the wall ceiling and partition. Here we use the facing material both. This is the 0.8 mm to 2.5 mm thickness, and they use for the stitching key. So this is for the screw, and this is the coach board. Coach board is used as a heavy duty facing for the timber. So they are hexagon heads. They use a spanner to tighten the bend. It is not practical to a stud. Special hollow facing will be required. All these solids are wall plus will not do, since they rely on the expansion within the wall material. So to rely on the strength of the plaster bolt to carry the load, so the heavy item cannot be fixed. So this is for the when you are using the plaster bolt, there are limitations. You can't fix the heavy item. Here also you see the coach board. So that this is a typical plus for the heavy hollow wall facing. We need to check out the suitability for the particular situation. So it is a threaded plaster bolt anchor, doggy anchor, spring doggy anchor, hollow wall anchor, and nylon dog anchor. So the threaded hollow wall anchors they are figure here. They can be the fillet, reset head, and timber body. They attaching the lightweight, and we can use for the plaster bolt thin wall prevailing. So that in this case, we screw into the plaster bolt attached to the facing. Doggy anchor, this is a side figure out the doggy anchor. There's a load in the attaching the lightweight. We can use for the plaster bolt. We have to use. They are using the cell railings, moving doggy to provide the clamping force inside the set tapping screw tied on the swing doggy to inside the plaster bolt to clamp for the clamping. This is a spring doggy anchor. This is a figure out the spring doggy anchor. Two spring look at arm, flip out where inside into the mounting head. So load can be the low, medium, and also plaster bolt we utilize. They rely on the gravity for the doggy to hand square to the thread. The method is an anchor is inserted through the mounting hole and press against enough face of the bolt when screw is tightened. So this is for the spring anchor, doggy anchor connection method. The doggy loose is the screw is undone. The drain hole size must be the larger enough to allow the doggy to pass. So this is for the facing of the doggy anchor, spring doggy anchor, the fitting. So in this case, you have to check the no cable or the pipe hidden in the wall beneath area to be the drain. So this is before that you are facing this one, you need to drain. Therefore, you need to check any cable or any pipe. Then after that, you can fix a doggy anchor like this. So this is doggy anchor fixing. So this is the spring doggy anchor. Spring doggy anchor. Here is a hollow wall anchor. Hollow anchor is you can use the collapsing less you also utilize. So the collapsing less that's expand when the anchor is pushed to the hole. So we have firstly you have to grade, you have to put the anchor, then less expand, and then we can fix the other thing. So this is the fitting method for the hollow walls anchor. They got the advantage. the screw can be removed without losing the anchor once it has been seated and the anchor is bent. Here is nylon torque anchor. They are bigger, their load is a light duty, and we can use for the cavity of solid wall. So then we also follow the hollow wall anchor method to fit the nylon torque anchor. So that we have to provide the extra support for the heavy fixer. To fit the heavier item to the hollow wall, a more permanent method must be advised to offer the supports. When the timber do not line up with the fixing, a suitably sized timber knocking can be used to bridge between them, and submissions are strong to support the weight. So they are important aspects. Here is this is the diagram, the row diagram shows the torquing anchor, hollow wall anchor. This is a different wall fixing method. And here is we can use a hollow wall anchor, torquing anchor diagram to show that this is a screw, and this is a nylon screw, and this is the nylon anchor diagram, and this is a diagram of the solo wall anchor. Torquing anchor, hollow wall anchor. You can see this is the fitting clamp. The fitting clamp, and also that you have to do this exercise. So you have to mark out and you have to fix the item. Okay, this is we are talking about the electrical trade, electrical engineering science, Bachelor of Applied Engineering, and Trade 2 and Trade 1. Trade 2 is we talking about the heater, and Trade 1 is we are talking about the material used in the electrotechnology, and also the fittings of materials. We are talking about now. We are talking about the advanced diploma. Okay, last week we have finished the electrotechnologies program. Now we are continue. We first go and look at the advanced diploma, electrical diploma 2022. This is electrical diploma 2022. So we continue this video. Last week we finished at E029 electrotechnologies program. Now we continue the next lesson. Now we are talking about the engineering physics, the motion around a straight line.
The motion along the straight line. So this is the initial place here, final place here. So distance between the initial to final place and displacement. So speed can be calculated to the distance traveled divided by time. So this is the speed, and velocity and displacement divided by time, and acceleration and velocity by time. So this is for the motion along the straight line. We're going to use the no formula. Okay, so this problem, a car is driven along a straight road for 8 by 4 kilometer at 70 kilometer per hour. At which point, the gasoline will run out and stop over next 30 minutes. Then the driver walks in another 2 kilometers to the petrol station. What is the overall displacement? B. What is the time interval from the beginning of the drive to final destination. C, what is the average velocity? So that the withdrawn of operation, so that 8.4 kilometers are drive the car, and here this point the petrol run out, and 2 kilometers are walk. And here is reached at the petrol station. So that this is what is our walking distance is at 30 minutes or 0.5 hours. So then we can calculate overall displacement. 8.4 plus 2, so you got the car. Driving distance plus walking distance, 8.4 plus 2, so 10.4 kilometers. And to the time is the time for the driving plus time for the walking. So the time for driving the distance by velocity, time for walking the 0.5 hours. So distance is 8.4 kilometers, and velocity is 70 kilometers per hour plus 0.5, so you got it 0.62 hours. And then we can calculate the average velocity. So the overall displacement divided by overall time. So this is the 10.4 kilometers divided by 0.62 hours, so 16.8 kilometers per hour. So this is the way that we drive the car. So now we can draw this moment on the velocity graph. So the horizontal velocity, vertical position. So this angle theta. So this is the horizontal side, vertical position. So this is angle theta. The angle theta is the velocity. So H1, Hy by Jh. This is the vertical position. This change Hy, horizontal change and Jh. So Hy by Jh is the velocity. In the meantime, we can write down here. This is what we add the velocity and constant velocity, the velocity going down. So in this case, this is from the T1 to T2, this is the positive acceleration. And T3 to T2, this is the negative acceleration. So this is the displacement graph, velocity graph, and the acceleration graph. For this program, the following of data represent the plot for the elevator here. That is the initially stationary, then both up and the stop. Plot the velocity graph. So initially the 4 kilometer by 3 seconds and go to the final 24 meter 8 seconds. So the average velocity is going to H2 minus H1 divided by T2 minus T1. So the 24 minus 4 divided by 8 minus 3 is equal to 4. So that was 0 to 3 are going up. So here is the 4 kilometer are going down, and from here that is stopping. So this is what is our velocity graph.
Next lesson, constant acceleration video.
In this program, the following equations are given the position h of the particle in the full situation, h in meter, t in second. So when the t is greater than 0, so a is at 3t minus 2, b is at h minus 4t squared minus 2, and a is at c that 1 by t squared, d is at h squared minus 2. In first situation, is the velocity below the particle constant, b is at in which b in the negative direction. So that this is a h will be 3t minus 2, so we got the differentiate. So velocity is dh by dt, so you got this 3 meters per second. And b, a is a minus 4t squared minus 2, so b is a dh by dt, so you got a minus 80. C is a 2 by t squared, so this is a 2 over minus 2, so dh by dt squared 2 minus 4t over 2. And d is a minus 2, so differentiate, so this one is a 0. So in this case, you see C is a. A is a you call the final differentiation of 3. So A is a constant velocity. B and C are all coming out with a negative, so that this is negative velocity. DK is a no velocity. So this is a constant acceleration. Constant acceleration with the position and the time in the graph. So velocity is a straight line, acceleration is a constant line. So when the constant acceleration, we can use this formula. Final velocity V is equal to V0 plus AD, initial velocity plus AD. And this here is equal to V0 divided by half AD squared, and V squared is equal to V0 squared plus 2AS. In this case, V is the final velocity, V0 initial velocity, A is acceleration, D is time. A is a delta, S is displacement. Okay, this problem. The following equations are given the position H of the particle in the four situations. A is equal to 3D minus 4, B A is equal to minus 5D2, minus 4D squared plus 6. D A is equal to 2ID squared minus 4ID. D is A is equal to the 5D squared minus 3. So to which of these situations do the constant acceleration formula apply? So firstly, you write down the equation A is equal to 3D minus 4. So you differentiate this by dt. So you got a 3. d2 by dt square is dA by dt3, so 0. So this is that's not applied. And P is a minus A is going to minus 5 d power 2 plus 40 square plus 8. So first differentiate dA by dt, you got the minus 50 square plus 80. So d2 by dt square, so you got the minus 30 plus 8. So it does not apply. And C, A is going to be minus 2 power 2 d power minus 2 minus 4 d power minus 1. So dA by dt is, so you got the minus 4 d power 3 plus 4 d power minus 2. And d2 by dt square is minus 12 d power minus 4 minus 8 d power minus 3. So this is does not apply. And dA is equal to 5d square minus 3. So dA by dt is 10d. So d2 by dt square is 10. So here you got a constant. So that only dA's constant association is applied. Okay, this problem. A pitch has a toss in the baseball. Up along y-axis with the initial velocity 12 meters per second. A how long does the ball take to reach is the maximum height. B, what is the maximum height? Above is the release point. And C. So how long does the ball take to reach the point 5 meters above its release point? So the first result that it is initial velocity 12 meters per second. So when it reaches the maximum y, so final velocity be 0. Acceleration against the gravity, so minus 9.8 meters per second square. So we write down d is going to be 0 plus 80. So 0 is going to be 12 plus minus 9.8 t. So t is going to be 1 by 2 seconds. And second thing, the maximum height. So the v2 square is going to be 0 square plus 2ah. So final velocity is 0 square, initial velocity 12 square, and the 2 is a minus 9.8. So here you got the h is a 7.3 meter. And then there's a 5 meter. 5 meter means we write down the equation h is going to be 0 t plus half ad square. So 5 equal to, so b0 is a 12t plus half is a minus 9.8t square. So 5 you got is a 4 by 9t square minus 12t plus 5 equal to 0. So we compare with the equation a square plus b plus c equal to 0. So a is equal to minus b plus or minus square root of b square minus 4 is like 2a. So a is equal to the u substitute. So the b is a minus square, is a 4 by 9, s is a 5. So by solving this one, the t value is a 0.53 or 0.19. So based on this motion along the straight line, so you have to do the follow study. Topic 1, motion along straight line. Study the slide 1 to 13, do the exercise question 1 to question 5.
Now we're talking about the beta.
So beta means that beta has a magnitude and direction. So from A to B, both are 4 units. So this is the A to B beta. A to B beta has a magnitude. So that we can add the A and B beta. A beta that direction, B beta that direction. So A plus B beta is this one. And this is the B beta direction, A beta direction, so B plus A. So A plus B is equal to B plus A. A plus or minus A is equal to 0. So this is the beta summation. So this problem, the magnitude of the A is 8 km due east, B is 2 km 30 degrees north of the east, C is 1 km due west. What is the greater distance at the end of the task displacement? So this is A beta direction, this is B beta direction. So A this direction B 30 degrees, so C is reverse. So that we get H. So this is A2, B, A is 2, and this is B2, A direction here. So this is the A direction. So A is 8, the B is 2, and the C the bar is 1. So this is the we measure the distance. This is the 4 by 8. The component of the beta, we can divide the beta value beta. So this is A, this is angle theta. So this A is A cos theta, AY is A sin theta. So tangent theta can also be calculated AY by A8. So theta is equal to tangent inverse AY by A8. So we can add the beta component. So we can add the A beta here. This is A is AY, the B beta BH BY, C beta CH and CY. So we add the all beta component RA is equal to AH plus BH plus CH. RY is equal to AY plus BY plus CY. So the total R is equal to square root of RA square plus RY square, and the tangent inverse RY by R8. So this is for the adding the beta component. So this program is A beta is 4 by 2I minus 1 by 5J. And B beta is minus 1 by 6I plus a 2 by 9J. C beta is a minus 3 by 7J. So we have to add the resultant beta. So we add this A plus B plus C. So this is 4 by 2I minus 1 by 5J plus minus 1 by 6I plus 2 by 9J plus minus 3 by 7J. So that will be 2 by 5I minus 2 by 3J. So the resultant beta is equal to the 2 by 5 square plus 2 by 3 square and minus tangent inverse 2 by 3 by 2 by 5. So 3 by 5 and get minus 41 degree. And scalar product. So A beta is A1I plus A2J plus A3K. And B beta is B1I plus B2J plus B3K. So A dot B. A dot B is the just magnitude. A1 and B1 magnitude. A1 B1 plus A2 and B2 magnitude. A2 B2 plus A3 and B3 magnitude. A3 B3. So therefore that's A dot B is equal to 3 multiplied 2 plus 4 multiplied 1 plus 5 multiplied 3, so you got that 25. Another one is the beta product. So the A beta is A1I plus A2J plus A3K. B beta is B1I plus B2J plus B3K. So that A cross B. So we had to write down the matrix IJK here. So that this is A1, A2, A3, B1, B2, B3. So the first thing you assume that I. When you take the I, the whole row, the whole column and the whole rows are forget. A2, B2, A3, B3, right. And also this are minus J. Minus J, so the whole column and the whole rows are forget. Write down the A1, B1, A3, B3. A1, B1, A3, B3. And the plus K. So the whole column, the whole rows is forget. And so write down the A1, B1, A2, B2. So that this multiplication, the positive, this one negative. So this one multiply positive, this one negative. This will be multiply positive, this one negative. So this is the I multiply A2 B3 minus B2 A3 minus J A1 B3 minus A1 B1 A3 plus K A1 B2 minus B1 A2. So this is the total beta. This is the cross product.
Beta full mass acceleration.
So this is a beta is a 2I plus 3J plus 4K, B beta is 3I plus 2J plus 2K. So we have to find this A cross B and a B cross A. So firstly we write down the A cross B, IJK, A beta 2, 3, 4. So 2, 3, 4 we 4, and B beta 3, 2, 2. So 3, 2, 2 we 4. So firstly we start with the I. The whole column, the whole row forget. So then write down 3, 2, 4, 2. 3, 2, 4, 2. So this guy is multiplication positive, this is a negative. And then negative G, the whole column, the whole rows are forget about. So write down 2, 3, 4, 4. So 2, 3, 4, 2. So this is direction positive, this one is a negative. And plus K, the whole column, the whole rows. So neglect. So write down 2, 3, 3, 2. So 2, 3, 3, 2. So this direction positive, this direction negative. So that this multiply 3 multiply 2. This direction multiply 2 multiply 4. Minus J, so this will be multiply 2 multiply 2, that direction 3 multiply 4, plus K. This direction multiply 2 multiply 2, this multiplies are 3 multiply 3. So that will be finally what you call is a minus 2I plus 2J minus 5K. And for the B cross A, so write down the IJK, by the B first, B beta is 3, 2, 2, by 3, 2, 2. And A beta 2, 3, 4, 2, 3, 4. So that we start with I, so that write down 2, 3, 2, 4. So this is the whole column and the whole row of forget. So 2, 3 and 2, 4 you write. And minus J, the whole column, the whole row forget. So that 2, 3, 2, 2, 4. Write down. For the K, the whole column, the whole rows are negative. So write down the 3, 2, 2, 3. 3, 2, 2, 3. So that this direction is positive, this direction is negative. So 2 multiplied 4 and minus 3 multiplied 2. So this direction is positive, this direction is negative. 3 multiplied 4 minus 2 multiplied 2. So this is positive, this is negative. So 3 multiplied 3 minus 2 multiplied 2. So all the thing what you call is a 2i minus 8j plus 5j. So we made the comparison. Here is minus 2i, this is plus 2i. Plus 2j, so minus 8j. And minus 5j, this is plus 5j. So that in this case, A cross B is equal to minus B cross A. So based on those methods, you have to study. So study the side 1 to 13. Do the exercises are question 6 to question 11. Another one is 4. 4 is a multiplication of the mass and acceleration. F is equal to M multiplied A. So this problem, a 2 kilogram tin is accelerated at the 3 meter per second square in the direction shown by the A vector over a frictionless horizontal surface. The acceleration is caused by the 3 forces. What is the third force? So this is the F1 is particularly 10 Newton. So this is the 30 degrees, so F2 10 Newton. This is the F3, so this is the 50 degrees. So firstly we have to calculate the F net, M multiplied A. So the net 4 is the acceleration 3, and net 4 is 2, so 2 multiplied 3, so 6 Newton. Then we write down the equations here. So then go to the 4 or go to the right hand side are the positive, go to the left are the negative. So the right direction 4 is the F3, left direction 4 is the F2 cos 30. So this is the and this is for the sit angle 50. So this is for the F2's cos 30, this is the left direction. So F1 is not participate because of totally particle. So that becomes F3 minus 10 into 0.866 is 6 cos 50. So from here you got the F3. So the two weights are that they are balancing. In this case, the resultant force is equal to the N1G minus M2G divided by N1 plus N2. So this is for the force is line on here. So the particle Fn is equal to Fg. And here is a tension T. T is pulling the mass, acceleration A. In this case, T is equal to M into A. And this is the balancing force. So this is T is pulling here, this one is leaving up. So the T is equal to M into G. And for the friction, it's a mass. Mine is a line on the friction plate. So this is the particle force at Fg equal to M into G. And the coefficient of friction is mu. So the T is equal to Mg into mu. And the particle force at Fi is equal to friction force is equal to Fg into mu. So the Mg into mu. This program. So this is the inclined plane. Inclined plane, this is the T. So this is angle T. T is at 25 Newton. So A cause of push on the power allowing frictionless plane. T is at 30 degrees, mass is 5 kilogram. We have to find the acceleration. So this is the 25 Newton. This is the F. So this is the going down the 5 kilogram. So this is T is 30 degrees. So this force is the mg cos theta. And this particle force is mg sine theta. So that we have to calculate. So this is for this force is theta here. So this is the mg cos theta. So this force will get mg sine theta. So this mg sine theta is equal to horizontal Fh. Fh is equal to mg sine theta. So that 2 into that. M is 2, G is 9.8, sine theta 0.5, so 24.5. So that this force is at T here, this is Fa is at this direction. This Fa is at mg sine theta. This Fa is equal to mg sine theta. So that F net is equal to T minus Fa. So tension is at 25 Newton. Going down force is mg sine theta. So this is for the M is 5, G is 9.8. 99.5 to 24.5. So 25 minus 24.5 is 0.5 Newton. So acceleration A can be calculated net force divided by mass. So net force is 0.5 Newton, mass is 5 kilograms, so you got the 5 meter per second square. Based on the force and acceleration, you have to do the further study. Start the slide 1 to 4, do the exercise question 11 to question 13.
And we're talking about the uniform circular motion.
Uniform circular motion. So if the participant is moving around the circular path, so it is have the acceleration. Acceleration is perpendicular to the circular motion path. So the acceleration can be calculated v squared by r. In this case, a is the centripetal acceleration, v is the velocity, r is the radius of the motion. So the centripetal force can be calculated. Force is equal to mass multiplied acceleration, F equal to m into a. So the a is the v squared by r, so you call that mv squared by r. So these forces are the two forces. One is a normalized force, another one is a gravity force. So this normalized force and the gravity force are combination is equal to mass multiplied v squared by r. So we can write down all of the how much do this r. So the minus m minus mg is equal to m multiplied minus v squared by r. So this is the uniform circular motion we can calculate by this equation. Okay, this program, the circus performer is riding a bicycle in the loop, which radius r equal to 2 by 7 meter. What is the d speed at the top of the loop and 4? So this is the circus performer riding a bicycle here at the top. So we have to find the speed. So in this case, the mass is 220 kilograms, and radius of the loop is 2 by 7 meter. So we can calculate force. Centripetal force is equal to mv squared by r. So I is 20, and also the velocity v. So this is for the v squared. So velocity v is have to calculate. Firstly, we have to calculate the force. So that we write down the equation minus Fn minus mg is equal to m into minus v squared by r. So the Fn is 0 at the top. So this is 0 for mg. So mass and the zero gravity and the minus v squared by r. So this I know, r is we already know the 2 by 7. So by solving this one, we got the velocity v. V is 5 by 1 meter per second. After the force can be calculated, force is equal to mv squared by r. So mass is 20, v is 5 by 1 square, radius is 2 by 7. So you got the 192 Newton. The next program, suppose that the coefficient of the static friction US between the riders are clothing and the given is 0 by 4 and the cylinder radius r is 2 by 1 meter. So A, what minimum speed B, mass the cylinder and the rider F if the rider is not to fail when the flow drop. And B, if the rider mass is 49 kilograms, what is the magnitude of centripetal force? So this is the rider here. The rider is the riding. So this one is the riding. So this is the circular motion. So the Fn can be calculated mg by us. So the minus Fn minus mg is equal to m into minus v squared by r. So in this case, r is 2 by 1 meter. So in this case, we can substitute here. Minus Fn is equal to minus mv squared by r. Do not pay means the Ufn is mg. So therefore, in the square of the Ufn, we can substitute. So in the place of the Fn, we can substitute mg by mu. So mg by Un is equal to minus v squared by r. Therefore, from the transposing this equation, mg by U is equal to mv squared by r, so the v is equal to square root of gr by us. So we got to substitute here the 9 by a1, and I is 2 by 1, U is 5 4, so you got to 7.2 meter per second. And then the Fn can also be calculated mv squared by r. So then m is 49, velocity v is 7.2 square, radius I 2 by 1, you got the 1 on the 200 Newton. So this is for this problem, this answer here. Now I the drag force and the diameter speed. So the beavers are sliding, so similarly the serving, so this is the serving here. So this this flow is a drag force, so this is a CP. CP is a drag coefficient. So D is a drag force, CP is a drag coefficient. So the sub area A is equal to a 30 cross the area, and the velocity moving with the subbing is a velocity. So we write down the also equation. P minus FG is equal to MA. So this equation. So in this case, A is equal to 0. 0 is as I'm moving at a constant speed. So that P minus FG is equal to M into 0. So therefore, the D is equal to F into G. So that this D, the D is a formula is a CP, coefficient of the traveling area A, traveling area multiplied B square is equal to FG. So the B is equal to square root of 2FG by CP multiplied A. So this is the drag velocity can be calculated. Square root of 2FG, 2FG is the drag force, by CP the drag coefficient, A is the area. So in this problem, if a falling gas are reached in the first terminal speed of the 97 km/h, while it is stuck in and then stretched out, doubling the A, how fast is it falling when it reaches the new terminal speed? So this is the original terminal speed is 97 km/h, and another velocity P2 have to be calculated. In this case, V is equal to the square root of 2FG by CPA, P1 is the square root of 2FG by CPA1, P2 is the square root of 2FG by CPA2. So the P1 by P2 ratio is the square root of 2FG by CPA1 divided by 2FG by CPA2. So that we call the thing is the square root of 2FG by CPA1 multiplied by CPA2 into 2A2. So the A2 is a 2A1. A2 is equal to 2A1, formula in A. A2 is equal to 2A1. So A2 is equal to 2A1, so that is the place on the A2 we establish with 2A1. So 2F, so by solving this one, 97 and B2 is equal to square root of 2, so the B is equal to 68 km/h.
Unibound circular motion. Those are lesson written notes for the those video you can see from this side. If you don't highlight computer select video lesson. So page 58 to 86 is the engineering phase. So that all the video written notes you can get from this side, and you can read the page 58 to 86. And the last one is uniform circular motion. The last lesson for this week.
So based on the circular motions theory, you have to do the balance study. Set the side 4, and set the topic for circular motion. So start with the side 1 to 9, do the exercise question 14 to question 18.